Students, today we are going to derive the equations of motion, all four equations using the calculus method. The first equation of motion is V is equal to U plus AT. They are all deduced for a uniformly accelerated motion. Now in this, V is the final velocity, U is the initial velocity, A is the acceleration and T is the time. Acceleration can be defined as change in velocity by change in time. So we can write it as dv by dt. Cross multiplying, we can write dv is equal to a dt. Now we are going to integrate these two. The integration for dv will be between the two velocities from u to v, and dt will be from the time 0 to t. What it means is कि जब वो ऑब्जेक्ट 0 से t टाइम तक जा रहा है, at that time उसकी velocity u से v में change हो रही है. Now since acceleration is constant, we can take it out. Integral 0 to t dt. Now integral of dv, that is v from u to v, is equal to a is constant. Integral of dt is t from 0 to t. So putting the values, in case of v, we will do v minus u. एक बार ये वाली value minus ये वाली value we'll put in the v. So v minus u is equal to a. For t, we'll put t and 0. So t minus 0. Or v minus u is equal to at. Or v can be written as u plus at. This is the derivation for our first equation of motion. Second, we are going to derive S is equal to ut plus half at square. Now velocity, it can be written as delta S by delta t, that is change in displacement by change in time, or we can write it as ds by dt. ds can be written as v dt, and in place of v, we can write it as u plus at. We just derived v is equal to u plus at. So we can write u plus at in terms of v. Now taking integration for ds, the displacement is happening from 0 till s, and dt, that is the time, is changing from 0 to t. So integral of ds, it will come as s from 0 to s. Here we will have two separate integrals, 0 to t u dt plus 0 to t at dt. Here u is constant, so we will have 0 to t dt, plus here a is constant, so we have 0 to t dt. For s, we'll put the values s and 0. This will give us s minus 0. So s minus 0, that is s, is equal to u. Integral of dt, that will come as t from 0 to t, plus a, integral of t dt. So we know the integration formula. Integral of x to the power n dx, it is written as x to the power n plus 1 by n plus 1. So this is t to the power 1. So this will become integral 0 to t to the power 1 plus 1, that is t square, by 2. Or we can say s is equal to u, putting the values of t and as t and 0, t minus 0, plus a. We can take even 2 outside as it is a constant term. So a by 2, and we have t square, where we are going to put it as t and 0. So we are getting s is equal to ut plus a by 2. We have t square minus 0, which is ut plus half at square. So this was the second equation of motion. Now we are going to derive the third equation of motion, that is v square minus u square is equal to 2as. We can write acceleration as dv by dt, but in this equation we do not have any time. So there is no term with t here. So what we do is we multiply it by ds, and we can write, by shifting the denominators, we can write it as dv by ds into ds by dt. Or we can write a is equal to dv by ds by dt, that is change in displacement with respect to time, that we can write as velocity. Or we can write a ds is equal to v dv. Taking integration both sides. So with respect to ds, the displacement is happening from 0 to s, and with change in velocity which is happening from u to v. A is constant, so we'll have a 0 to s ds is equal to, in this case, we will have integral v dv. So again we are going to use the same integral formula. Integral of x to the power n dx is x to the power n plus 1 by n plus 1. Now here the power of v is 1. So we can write it as v to the power 1 plus 1, which is v square by 2 between u and v. Here we have a, integral of ds will be s. So putting these values in v square, we have v square by 2 minus u square by 2. Or we can take half common, v square minus u square. Here we have a, putting the values s and 0, we have s minus 0 is equal to half v square minus u square. So this becomes s, and this 2 can be cross multiplied there. 2as is equal to v square minus u square. This is our third equation of motion. The fourth equation of motion is s nth is equal to u plus a by 2 into 2n minus 1. Basically, here we are finding out the displacement which happened in the nth second. The displacement which will happen in the nth second can be written as Sn minus Sn minus 1. यानी कि 0 से लेकर अगर हम nth टाइम या सेकेंड तक टोटल डिस्प्लेसमेंट में से 0 से n minus 1 तक का डिस्प्लेसमेंट माइनस कर देते हैं, तो we are able to get that what is the displacement which happened at the nth second. So we are going to derive this equation. Here we can write ds by dt as v, or we can write ds is equal to v dt. V can be written as u plus at into dt. Taking integral, so here we take from Sn minus 1 till Sn. And for dt, we are taking the time from n minus 1 second till n second. So integral of ds, it will come as s between Sn minus 1 to Sn is equal to, this integral we can divide it into two parts. Integral of n minus 1 to n u dt plus integral of n minus 1 to n at dt. So this side we have u is constant and integral of dt, that will come as t from n minus 1 to n. Here a is constant and t dt, using the integration formula, we will get t square by 2 from n minus 1 to n. Here putting the values of s here, s of n minus s of n minus 1. As I told you, this is the displacement in the nth second. So s nth can be written as u. In place of t, we are going to use n minus n minus 1 plus a. I can take 2 also as constant, so I'll just bring it out. So in place of t square, we have n square minus n minus 1 whole square. This will become u plus a by 2. Let's solve this portion. So this we will have n square using a minus b whole square formula, a square plus b square minus 2ab. So after this is there. So Sn can be written as u plus a by 2. Solving this all the signs will change because there is a minus sign before the brackets. N square and n square will cancel and we will be left with 2n minus 1. This is the derivation of the fourth equation of motion. If you liked the video, please like, share and subscribe. Thank you.